Hello and welcome back with Mr. Elison. We're happy to have you with us. We've just been investigating volume of several different solids, and if you'll remember from our last discussion, we talked about cylinders and their volume and the formula for that. Today we want to do a little investigation on cones to add to that and kind of see what the difference is or what the similarities are and investigate that. So I have here, I've created a cylinder and a cone, and I want to investigate those. And you'll notice I've created the same dimensions with both of them. The radius is the same, the base of both are the same, creating the same size circle in the bottom. You'll notice also that they're the same height. I've tried to create the exact same dimensions of these two, but you'll notice that the cone is going to taper, so that's going to create a difference for us. Now, how these two relate is I put this cone inside of the cylinder. I can tell that the cone's going to hold less, and the question of the day might be, how much less? So we want to look at that just a little bit here, and I've got the software running so that we can investigate this. I'm going to be able to fill up the cone. You'll see it turn blue, and we'll be able to fill it up, and then we're going to empty those contents into the cylinder, and you're going to see what happens. Notice that I've got the radiuses and the heights all set the same, and I can play with that and make them different sizes. But the overall is that we'll be able to investigate what it'll do. And here we go. It's a full blue cone. And as I empty the contents of the cone, you'll notice that it fills the cylinder about a third of the way full. That tells me that we're probably going to get 3 cones in that cylinder. And that's an interesting thing to look at as we've talked about the formula for cylinder. I wonder how the formula would relate for a cone. And it doesn't matter if I change the sizes here of the cone and the cylinder, but again, keeping the surface the same on the bottom, the face of that. And again, as you see me empty the contents in, we get to that point where it still fills it to a third. So that's the investigation, and as we look at that, we can then see that it's going to take 3 of those cones to fill that cylinder, and that's a handy thing to know. And so when we get to the formula, all we have to do with the formula from a cylinder is to divide it all by 3, and we've got ourselves a cone, and that's how we get this new formula for a cone. No wonder soda, no wonder my Coke is in a cylinder instead of a cone. It holds 3 times more. It does make me wonder, however, am I getting my money's worth when I buy a snow cone? Thanks, and we'll see you next time. Have a good day.